All right. 2 tries. On the first one here. It's awfully dim.
Hey, everybody. Can folks hear me? Cool.
Hey,
Hi.
how you doing?
Hi all. Good. I'm gonna wait maybe a minute more or something to see if anyone else is gonna show.
Hi.
Hello.
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 All right. Let's do it. So thanks for coming. Sorry I wasn't here the last couple weeks. It's been tumultuous, and then GopherCon was last week too. So I saw we have a big item on the agenda this week for Bjorn asking if someone wants to give an intro to memory and CPU profiling.
I'm not sure if it's that big, but I was just wondering if
Yeah, it's definitely a topic. It's bigger. It's a big topic because there's so many ways to do it.
Yeah, that's why I tried to do some Googling and just see on examples. And like with a lot of things with Go, I've kind of fallen off and picked it up a few days later and tried again and so on until I understood it. But when I did this thing now yesterday, I thought I'm going to ask this in the study group and check if someone can give a short guide and hopefully, yeah.
Cool. Yeah, I think we can do that. Was there anything else that folks we didn't get to like last week or in the past couple of study groups? Cool. All right. Yeah, so who's got any ideas about memory and CPU profiling? Has anyone done it before or heard anything about it or anything like that?
The only experience I have really is doing a lot of benchmarks and tests. And when I run Go test, I give it a dash bench mem is one way to just see the output from your test and compare how many allocations are done using one algorithm or another. And then obviously the fewer allocations that are made, that, I think it's more efficient if the garbage collector doesn't have to, or the memory allocator doesn't have to run and provide those. So Go test has a dash bench mem option that I've used a lot. You can also, in the testing framework, you can also type, t dot report Alex. Let me put that in that. Was it t dot report Alex? I think is what it is, and that tells the Go testing infrastructure to report all the allocations for that particular test, so you don't have to remember to put it on the command line when you run your Go tests. So that's really the extent I have. If someone wants to add on top of that.
Yeah, I can add one. I've used pprof times. Let me get a link to it.
Yeah, it was pprof I thought about because I was reading some examples yesterday.
Oh, okay. Yeah, so usually I use that. I actually, basically when I write tests, a benchmark test like Carrick was talking about, I also put a little flag into my program, usually like an environment variable. And if it's set, then I'll install the pprof endpoints. It's just basically like HTTP endpoints that you can hit while your program's running. And it'll spit out basically like a flame graph of memory allocations and CPU activity and things like that.
Is that different than the CPU profile that I think what blog post that was done a number of years ago? When you like what you're talking about, is it different?
Do you know what the blog post is?
Yeah, I'm gonna look it up right now. I'm sorry.
That's cool. And there's another one I'll post into the Go Study Group Slack. There's this flame graph it's this like flame graph thing that builds on top of pprof that Uber built.
That I love. That is really, really awesome. You really can visualize. I pasted the blog post there, which is what got me started in profiling Go programs years ago. But that flame graph thing is amazing. You run your program, for a fixed amount of time or whatever, and then it spits out a profile, and you can run the flame graph, some flame graph utility. I think it's in Perl. And it spits out an SVG that you can open up in your browser and interactively explore the stack trace of what's taking up so much of your time. If you'd like, I can find a picture of that.
Yeah, I posted something in the blog on the chat from the blog at golang.org. But is one thing I didn't quite understand is when you start the profiling, you put it in your code, in your main code, but is that and it writes to a temporary file at some location on your hard drive. But is that something? Is it so you can continuously read from that temporary file, or is that file something you read after your program is
after
running?
Your program is done running? So basically, the in memory, it's going in while your program is running. It's not going to write to the file. It's just going to in memory accumulate a lot of information, and then you catch sig term or whatever it is, and instead of exiting right away, you turn around, or whatever your exit signal is, you spit out this blob into the file, and then you can use that blob after your program's done. There are other ways of doing it as well. Like you can hook into and get at the while your program's running, you can hit a API, like a HTTP API that it installs or injects into your code, and that will also give you introspection of what's going on.
So it is actually, but is that with pprof you can do that at runtime to see where, for example, your bottlenecks are at a given time, or?
I'm sorry, I don't know. I've not used that, but that would be cool.
I would say it's not an issue for me now, but I just found it interesting because I spend a lot of my time reading blogs and try to understand how this language works, and trying to also learn the important things. And I found this quite interesting, even though I haven't had any real use for it yet. But of course, I have to try to learn that as well.
So something that I read about a long time ago when it first came out from Russ Cox, but I never used it until GopherCon, and I was working with another gentleman, and he showed me it, and I'm like, oh yeah, that's exactly what I should have been using all this time, was a utility called BenchStat. And I just put a link into it, to the chat, to this library. And basically, if you write a bunch of benchmarks for your code, and you're considering making a change to how your program does something, you can write your benchmarks, run it a bunch of times, and just run your benchmarks like you always do, output the data to a file, and then change your code, do the same thing, run the benchmarks again, output the data to a file. And it's like a diff of your benchmarks, giving you the performance improvements or degradation that your code now has because of the changes you made. It's really cool.
Perfect.
And Holger said in Slack that pprof can create flame graphs without any tools starting in 1.11.
Oh, that's
I noticed, because I did a more or less copy paste from an example yesterday I found, and you can open this web interface and you get flame graphs as one of the options to watch directly in that web interface.
Awesome. Yeah.
So it's kind of cool actually, but I didn't quite get the grasp of the whole thing, so that's why I posted that topic in the document. But I'm happy. So I'm going to try to learn more about it.
Yeah, if you want just to answer one more question you had there, the HTTP pprof library, that's the one that I've used a few times. That's the one that lets you install HTTP handlers and run a server. You can run a server in a Go routine and then hit the endpoints whenever, and get the sliding window of profiling information.
Perfect.
So there's a, oh, and then Carrick, yeah, the bench stat tool that Carrick put up there, that's kind of a, I like that tool too. I haven't used it as much as you, I think, Carrick. Maybe,
No, I just started.
Can I recruit you for a demo of that sometime?
I just started using it, and I could definitely demo it if that's something someone wants to see, or if we have some time. Because some people asked me about incorporating my GoDirWalk stuff into the standard library. I was working on that at GopherCon, and I'm sorry I missed your lightning talk because I was doing that all day. But it was really, really awesome to work on. And so far, I've got the standard library going about twice the speed on my laptop, just walking the Go source directory. So it's not as aggressive as I knew I could do it with GoDirWalk, but because I wanted to hook into the existing API and provide very discrete access, like adapt it to work with the existing system, so we're changing less in the standard library, additive as opposed to modifying it, and just use a different function. So it, but I was using that bench stat quite a bit to evaluate changes I was making to the standard library to make sure I was not introducing any slowdowns in the standard library at all. Because in my book, I think that would be a disqualifier. Nobody wants a slower standard library, right? So the standard library's got a bunch of benchmarks in the source code for the standard library, and I would run it 5 times in a loop. I'd say go test bench, in a loop 5 times, output and concatenate to a file, and it just looks like this big blob of running tests and outputting benchmarks. You do that before, and then you make your change, and you do it afterwards. And BenchStat actually figures out which benchmarks correspond to which other benchmarks because of the labels, and it identifies the percent deviation, the min-max, and stuff like that. And it compares how fast or how slow you've made the code now with a percent change. So it's pretty well designed.
Cool.
I think I'm going to leave and rejoin because my camera is wrong, but I'll be back in a minute.
Cool. So other folks in here, does anyone not been here and wants to introduce themselves, by the way? Didn't ask that at the beginning. Okay, cool. I think there are some new folks here based on names. So if you are new, welcome. If you're not new, sorry. But if you're new, welcome. This is a forum for anything and everything Go related that folks want to talk about. So if you've got something ahead of time, put it into the agenda document, and I'll post that into the study group channel. If you are not in the study group channel, it's called #GoStudyGroup, all one word, in the Gopher Slack. And if you don't have anything ahead of time, but you think of something during, just bring it up. That's all good. And if no one has anything, I'm going to wait for Bjorn to join again, but if no one has anything, then you all have to watch me live code on the backup.
And so, you are a brave man with your live coding.
Yeah. Well, that's what you all get if you don't want to talk about stuff, and I'm always happy to do it too. So yeah. Another thing I mentioned earlier, because someone asked about some topics, they asked about sync mutex and weight groups and channels and stuff like that. And I'm very happy to talk about those. Not necessarily, I don't have anything for it today, but I'd be happy to talk about it. There's another thing I called Go Buffer Line Scanner, or Gobbles, and which I love that name. But basically, it's a drop-in replacement for the line scanner in the standard library, but it will not give you an error if your line length is longer than let's say 4,000 characters, or whatever the standard library limit is right now, which is a constant max scan token size. So
we've used it at my company a lot because we wanted to scan logs and inject them into, make tail logs, inject them into a system go through Kafka and then some other log aggregation facility. And every time we got a line length in a log file that was longer than a certain constant number of bytes, the program would error. So Gobbles was written with that purpose in mind, to actually not give you an error and actually give you the full line. And it does that with pretty good performance. It is slightly slower, usually about 2% slower than the standard library. But what it does give you, because of that performance degradation, it does give you the certainty that your code is not going to pop. You're not going to get an error and unable to process a line when that happens. It will give you every single line. So that's a useful utility I found.
Nice. Gobbles.
Gobbles. It gobbles up lines.
If anyone was here last week, I wasn't, so forgive my ignorance of what happened. But I saw we had two items. Carrick, you just talked about Gobbles, but you also mentioned some practical concurrency patterns, weight group, mutex, and channels. So if anyone was here last week, can you kind of describe what happened, what we talked about? Bjorn, were you here last week by chance?
Yeah, I tried to log in, but I don't think there was a meeting last week.
Okay.
I think it because a lot of people were at GopherCon, or so I think it kind of went away.
Okay, sorry. I don't have redundancy yet. I can pick some of that up. Well, I wanted to talk though about error groups. They're kind of another concurrency tool, and I'll put the link to it in the Go Study Group channel. It's golang.org/x/sync/error group. So it's an experimental synchronization library. I might as well, I'm just going to share my screen so that everyone can see what I am talking about. Just give me a second to hide all my embarrassing internal, highly confidential Redditing. I do. So the error group it's on the over the covers. It's kind of a simple description, but it actually, there's kind of like three major things. So it gives you synchronization via Go routines, but it also captures the errors from each Go routine and propagates them back up to one kind of supervising Go routine. And then it also lets you cancel the things going on in the Go routines. So it's kind of more than just errors. And that's pretty kind of well exemplified in this code. And I've only used this library once, so I don't have like the complete hang of everything. But I thought this was a good example because you basically just create this thing from a context, and then you just go down, you loop through as many things as you want, and you just call g.go, and that starts a new Go routine. And it'll capture all the errors in here that each of these functions return. And then at the end, you can call g.wait, and it'll wait till everything is done, and it'll roll up all the errors that everything returned into one kind of master error. And then if that returns nil, then you know that everything was completed and nothing errored out.
This is really super cool. It's it like puts together some things that I've like had to put boilerplate in there all the time to do that. I like this a lot. Thank you for introducing it to me or us.
Yeah, it's
So
like,
this is basically for capturing errors in the Go routines.
Yeah, it's catching errors, and it's also doing like a wait group. So it'll run like X number of go routines, and then it'll say, okay, wait for them all to finish, and then it'll capture the errors too. Like I was showing on this slide, it'll like kind of roll them all up into one.
So this is a perfect example of how one would go about doing sync wait groups. Except for sync wait group, you actually have to specify how many things you want to wait for. With this, it's tracking that for us, which is really cool. But it's a great drop-in replacement, almost drop-in replacement for using sync wait group, but it provides error handling for it.
Mm-hmm. Did that make sense? Did my answer make sense, Bjorn?
Yeah,
Okay.
perfect.
Before this, I've used a lot of times where I'll use a sync atomic and I'll spawn a bunch of go routines, and if the inside the go routine, if there was an error, it discovers the error, it will overwrite whatever was in the sync atomic before with the new error. And then at the end, if there was any error, so it would only give you one error deep, but it was actually not very good, but this actually looks much more general and much better for many applications and easier to use.
Yeah, I like this API.
Yeah.
Another thing I was wondering is, since you can pass a context into with context, I wonder what happens if you cancel the context.
I bet they're doing the right thing, but your code still will receive that context, and your code still needs to handle it correctly.
Yeah, I suppose so.
I mean, look at the source code, I imagine, right? It's just going to call your stuff, and then in the example, let's see, where's the example? Just errors, parallel, pipeline, whatever. Yeah, so it's giving you a context, right?
The API doesn't give you one here.
Oh, I see. It's we just start closing over the open variable, the CTX open variable. So I imagine as long as you are handling that context with the cancel, it will work properly.
Yeah. This is interesting. Yeah, so I wanted to call that out. If you end up doing a lot of different Go routines and almost everything can error out, this is a good tool to use.
Quick question about that example code, if you don't mind.
Yeah.
Is there an advantage to making to assigning the function to a variable as opposed to just declaring it normally?
Do you mean this? Oh, this up here?
Yeah, top level.
A lot of times I do that inside of another function because you can't do, let me open up my editor here.
It provides a scoping to the function name.
Okay.
So you can't do like, oh boy, Zoom and editing code are not well suited. You can't do like this. And then you can't do another, oh boy. There we go. You can't do that,
Gotcha.
but you can do that. And then blah, blah, blah. And then later you can call my func, whatever.
Okay, cool. Thank you.
So looking at the source code for this library, it's extremely simple and a great example of synchronous, the synchronous programming that was asked about a few weeks ago, especially starting at line 52, where it actually is using a sync wait group and then using the once feature for sync once. It's actually setting the error only one time. Which is similar to what I was doing but my code, it was setting the last error that gets in would override it, not the first error. So this is definitely superior in every way.
Well, let's go look at sync once. That's a good one.
Yeah.
There's a lot of crazy stuff in here. But sync once is a pretty cool and straightforward one. Carrick, do you want to describe what's going on here? Or you want me to do it?
Oh, I just had to swallow my coffee. So the concept of once is you only want to do something one time. Let's say, I've got a use case I was helping a coworker of mine identify where he needed to do a very expensive initialization, but it was not always needed. So for the library he was using. So instead of doing an expensive multi-second initialization when the library first comes online in the init structure, only do it in the subcalls of the library that needed it. So if you've got, let's say, 3 calls, A, B, and C, and only B and C need this initialization, but A does not, then you only need to do this initialization in B and C. You can wrap it in a once clause, and the runtime will ensure that the once clause, the once is like a little guard that causes its object or target to only be executed one time. So in the example code here, we declare a once variable, and in true, wonderful Go style, the 0 value is perfectly usable. There's no initialization needed. And then we declare a once body. This is an example where we are giving it a name to a variable in your function. So this function is an anonymous function that's given a name local to a particular your scope. And then we want to make sure the once body is only executed one time, and we can see how it happens in the for loop, where we have we spin off 10 different Go routines, and the once body will only get executed a single time. So if you hit the play on that, oh, you already did. Never mind.
There we go.
There you go.
There we go.
So if you hit it, it will only execute it once, not 10 different times. And the benefit of this is we are allowing the runtime to handle the concurrency. If you look at this, it's very common in Go to spin up a bunch of Go routines, like on line 14, and in a loop. And when you do so, we don't know, it's indeterminate which Go routine will actually start running first. And even if one starts running first, the moment it starts doing its initialization, that Go routine immediately could get preempted and a different Go routine could continue. So to prevent race conditions, when you only want something to happen once in the whole lifetime of your program, or the lifetime of that variable declared on line 9 in this Go playground, then this will have the runtime guarantee that will only take place once. It's a very simple construct.
Are there restrictions on the signature of the function that you want to run once? Like, is it?
Yeah, yes. The restrictions are, if we go back to the documentation, you can see also on the example there, it's got to be a function that takes no arguments and has no return values. But if you see, can you click on the example once again, please? I know. If you see that your function could do anything and close over any variables inside, in this case, the function's not closing over any variables. Man, I should start screen sharing. But if we add an integer before line 9, like an integer.
Eric, I'm going to stop screen sharing. You can go ahead.
All right. Opening up. Let me open up once. Go doc. Go line. Let's see. I'll start screen sharing as soon as I pull it up. There we go. Sync. And then let me share. Sorry, guys.
It's cool. We all have Reddits we have to close.
Firefox sync. That's it. All right. So here I am in right where Aaron was a few moments ago. Can you see the screen, or should I? There. How's that?
Thank you. Works for me.
So if we go to the example and then maybe click on the play, and let me make the fonts larger. Okay, let's add a function, var counter int, and then I'm going to say counter plus plus. Okay, and then run. Okay, so I'm going to do one more thing. Oops, copy and copy paste encoding in a different editor is kind of weird. I wish it would go from the output here. Oh, it does. Sorry. There we go. Okay, so in this example, let me run it. We can see that the body is only executed or invoked a single time, even though the go routine executes many times, or 10 times. So that's all it's doing. It's just only execute this one function or the specified function a single time. Although you don't have to have, I was mentioning this earlier, let's func, put my finger on the home row, once body, of course, counter is now terrible programming here. Format. Oh, yeah. Okay. So in this case here, the body or the target of your once.do does not need to be a function that's an anonymous function. It could be a function that is defined normally and available globally. So it just, in the name of this, the name of the function has nothing to do with once. It doesn't need to have a special name, nor does this name. This is just our foo, copy, paste. The variable names are immaterial, but they're just a helper to us when we're looking at the code. So we're only going to run that function once, and the guard is this right here, where we say, hey, this foo is defined as a once instance of a sync once, and we're only going to do it one time. Okay, I think that. Any questions, or did I say anything badly?
So, but the purpose of doing something once, so for the application I'm thinking about, right, is let's say I want to like start a server and I want to like only connect to the database once and only once it gets like a call or something like that, right? So to control like the side effects without using global variables, I can either use like a closure or I can use like a method on a struct. Is that correct?
You can use a closure, a method on a struct. Well, if you had a server, I would definitely like have a new server
Yes.
function that would build it. And then of course it has its own data field that actually has a pointer to the server, and it will only initialize that once. Maybe I would do something like this, type my server, maybe this is what you're referring to. And this is kind of what my teammate had done. Init once is a sync once. And then we've got a DB handle, right? And then that's, let's pointer to, oh, I'm just going to call this DB is a map string to int. And that's a stupid example. But you can, at this point, you would not need an initialization, but you could say, ms my server, get int, get some string int, just use my values, and then ms dot init once do func, and then you can do the initialization a single time, and then return the msdd some string. All right, there's a really crappy example here. Maybe I would need to say that I okay equals, and then do something else. But maybe in the initialization function, you wouldn't want this to be a init db. And at this point, you would initialize the database, initialize your structure, do whatever initialization is necessary. So this is not really a great working example, but the case in point is you can specify to do something only a single time, and then the runtime will only depend, regardless of how many simultaneous calls come in, it will get called one and only one time, and then you don't have to worry about it anymore. Maybe that's what you want to do. Maybe it's, but you know, maybe it's also smart enough to just, if you always need the initialization, then new server is probably your right answer.
Sure.
I would do that because there's no reason to have the runtime doing it here. In this case, I don't think there's much reason to have the runtime check it every single time you call your one of your server methods. I think that would be a poor choice. But if it's a significantly large initialization, maybe you only want to do it, and you don't always need it. Maybe go.
Okay, thank you.
Sure.
And there was in the article, Bjorn, that you posted, there's this handle template function. Takes in a bunch of files and then returns a HTTP handler. And there's a use of once in there.
It's for loading the templates only the first time the handler is executed.
Yeah. So I think.
Where was that at?
I put a link in the chat. It's
okay. Got it.
One of Matt Ryer's blogs.
Yeah.
So I also found, sorry to interrupt, but sitting Googling now, I also found that they have written another package called resync.once. So actually, so the point is that, okay, you've done a thing once and later in time you want to reset it and do it once again. So I just had to laugh.
Oh, so you can trigger a reset, so the once value actually allows you to rerun it. You're saying?
Yeah, I can post a link in the chat.
Sure. It sounds very simple to do with a CAS around the.
What would you use that for, Bjorn?
No, I'm not sure.
Well, I mean, maybe you want to use it for initializing your. Initialize based off of reading a file of configuration values. And every time you get a SIG hub, you want to reload that. So the SIG hub might turn around and, I mean, that's a silly example.
Yeah, but that's the funny thing about Googling. You find a whole lot of things. So
thanks for this link to this article. It looks pretty cool.
Yeah, you also have a few other ones. That same author. So I found them really helpful because he kind of explains them and gives examples, and it's not big examples. And for me as a new guy coming to Go or programming in general, I found them really at least easy to understand.
Cool.
I would love to see some examples of how to use resync.
Yeah, here is the link to.
Oh, and you can call reset on it, and then it will execute again. That's cool.
Yeah, that's really cool.
Yeah.
Oh yeah, that's really interesting that so I would not do it this way, the way he does it in the source code. Where he's got line 20 where he loads it and he checks if it's 1, and if it's 1 he returns. I think a better way, I'm going to copy this into the playground real quick. Oh, and play.golang. Okay, format. Mind if I share?
Go for it.
Just playground. Cool. Move that away. Okay, so in this case, he's got his done, which is UN32. I am not sure why we don't use, or it does not use the alternative compare and swap, is it? And now I'm going to turn around and say Golang. I'm going to be stupid, but compare atomic. Go to atomic, get the documentation for it. Bingo. The network's so smooth. Okay, so this sync atomic package is a bunch of low-level primitives, and the library's already using it. And what I was advocating is this compare and swap function right here. And what that does is it's equivalent to, it's an atomic CPU guaranteed atomic operation to do all these steps in a single instruction. So what I would suggest is uint32, okay? So looking at that, it wants a pointer to the uint32, the old and the new value, and it'll tell you if it changed. So we definitely want to do o.done here. The old value is 0, and the new value is 1. Okay, and in which case, sure why we're doing a lock. Yeah, that's bizarre. I'm not sure about some. So I don't think you even need all of that, because all you're doing is you want to say you want one and only one function to ever be able to, hey, is the current value a 0? If it is, set it to a 1 and continue and return a true. So only one function will ever get the call to F. You never need to do this. This, I think, is a lot extra because maybe the library author doesn't know about the compare and swap operation.
I think they have to lock, though, while F is running, right?
No, because you've already set it. We've already set, like the compare and swap, one and only one process can, or CPU instruction will ever find that 0 in there and then be able to put a 1 there. And for this, the exact same code is necessary. You don't need, but you're just storing a 0 there. You're resetting it. There's no locking necessary at all.
But what if F is long running and another Go routine calls reset?
That's a good question, but the answer is it does the compare and swap before it calls F. So it guarantees that only one thing will ever call F, period. Now, if F is long running, it could take, maybe 30 seconds, but nothing else will call it because it does not set the value at the end of calling F. It sets the value before it calls F.
So I think the behavior has changed. I don't think it's wrong, but I think the behavior has changed because before only one F could ever be running at once. No, this is also the same. Only one F will ever be running at a time, and only one will ever run until you call the reset. Okay.
So you can only have a single F running because only one CPU thread will actually be able to set this. Once that's triggered, all right, let's do this. This is a great example. So let's say for our, let's do a walkthrough. And when we first start up the program, we know that Go runtime initializes the value done to a 0, uint32 equivalent of a 0, all right? And as our program runs, we don't need, all right, we're gonna change this to main, okay? And we're gonna put a func main here. Sound good? And for I equals 0, I less than 100, I plus plus. Okay. And we want to do the same thing we did before with that counter. So let's go ahead and put a var counter. And I'm just going to make this an int. And then I'm going to say, we're going to create a var, we'll call it a once again, and it's going to be a once structure. And then we're going to say, go func. Type, type. And then at this point, we want to only run, so say once do, and I want to say counter plus plus. Okay. And then all right, do we have thumped in here? No, we don't. So let's add it. Format. Okay, let me run it. We don't use sync. Pardon me. Don't need it. Run it. Okay. Oh, we're not waiting. Sorry about that. So let's, we will need sync, var, sync. Here's a great example of a wait group. And then I'm going to say, wait group add 100. And then we're going to wait group done. All right, so this is what, think of what someone else had requested to talk about. How do you do this? And it's very similar to the other example where we want to have a group of tasks that need to get done. And then we want to wait, spawn them all off, and then wait for them all to finish. And that's exactly what the wait group gives us. Okay. Undefined sync. Oh yeah. I'm so used to not having to do that with. Okay, so the counter is 0, but we've never actually done this. So here my entire example, you guys are gonna laugh at me now. Compare and swap, what did I overlook? We're gonna execute the function and we're gonna increment the counter.
I think you have to do WG dot wait.
What's that?
On line 44, does that?
Oh, why am I calling done? And then, yes, I'm sorry, guys. You would think I've done this before. Oh, they're all asleep. Okay, never mind.
Line 41, WG dot done.
So, I suck. Like I've done this so many times. I'm really mad at myself because now that I'm rushing, whenever I try to rush when writing code, I really make stupid mistakes, and it's a lesson. Okay, so in this case,
same here.
In this case, I'm going to do one other change, and I'm going to say, if I equals, let's say 50, once dot reset. Okay, and I want to assert that the value is actually going to be 2. We'll run it, and it's not because once again I'm storing 0 there.
Does the WG dot done have to be inside of the once dot do function?
No, actually, because you want this whole function to, you're going to spin off a function to execute something in a Go routine, and that when that function is done, you want it to actually execute WG.done, period.
Oh, okay.
So this is the whole thing with the compare and swap, and I know my example is rushed, so I did not do a good job, is it will check to see if the value is 0, and if it is, it will set it to 1 and return true. Once the value is set to 1, everything else that executes the compare and swap is going to see that the value is not 0, so it's going to return false. Therefore, only a single item will ever have will ever invoke the callback F. But looking at this example, I'm not seeing where my mistake is, probably because I rushed through the example. But if it's equal to 50, we're going to reset it. What am I overlooking? I'm adding 100. I'm waiting for them to all finish down here. At the end of,
because it's going to call, it's going to set the counter to 1.
Yeah, and then if I understand this correctly, won't it put the weight group to done after at the first run?
That's a very good question. So that's about sync weight groups. Let me dive into that a little bit. When you define a weight group, you specify how many items specify.
Yeah, of course you put 100. Of course, sorry, I didn't notice the 100 above.
Oh, okay, gotcha.
Yeah.
So yeah, a lot of people might put, instead, this is fine if you don't know it. In which case you want to do it inside or inside your loop, but never, ever, ever, never, 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 never do this.
That's what I've been doing all the time and didn't notice the 100 above.
No. You will have, and so like my whole example is terrible, and I'm sorry about that, but never ever put your ad inside the Go Funk because you have a slight race condition that could happen because let's say we did that, okay? Let's say we did this. We spin off 100 Go routines.
It will never quit.
If we spin off 100 Go routines, but they, for whatever reason, if the process scheduler or Go routine scheduler does not schedule them to run right away, it's going to end the loop. It's going to immediately execute line 50, and the counter or the weight group was never incremented if Go routines were never called. Does that make sense? So you always want to, in the main thread, always increment your ad. You will find weird race conditions where you're not actually. You could have leftover threads.
Yeah, I usually do the weight group ad before I run the Go function as the last line before running the Go. So I don't think I'm usually creating a race condition then, but I've never seen the parenthesis 100. I didn't know about that one. So.
Oh yeah, that's very, very handy. And all you're doing is incrementing a counter, an atomic counter. If you look at the library behind the weight group, how it's implemented. But let me take a look at this and compare and swap done 0, 1. Sync once, reset.
Carrick, I have an idea. I'm not sure if this is.
I think I know why.
But I wonder if in the loop, I'm not sure if this is right, but in the loop, you call once.do. So without the if, you're only going to ever get to 1. And the counter is only ever going to get to 1.
Right.
But then if you add the if back in, is that going to ever call reset?
Well, the plan here was only one time it would call reset. So on the 50th iteration, yeah. Okay, so take a look at this. Ready? I int. So there's the other thing. Whenever you close over, okay, this is going to happen very fast. And whenever you close over a or use a variable, there we go. So it's.
Oh, I get it.
I am so sorry, guys. Oops, nope, done. And I'm going to use the format feature to clean up the code some. So that we're going to kill that because the most common is to call add many times. Okay, what happens is that I happens and it resets. In the old code, it was resetting probably before we even spawned the first Go routine. So it would call reset before the very first one was incremented, and it would reset it. And let's run this. 2. So there's a really good example, and I'd love to talk about that. That's another nuance. And it obviously, I've done this for years, and it still tripped me up. So I'm sorry about that, and I'm happy to explain why I'm a dummy and I did that.
No, I find this perfect because we actually see someone. For me, seeing someone doing something I haven't seen before, and that you make some mistakes. That's also it being working alone, as I've been doing all the time. I wonder how good are other people, and do they always do things the perfect way? And when I read the blog posts and I watch the YouTube videos, which have been clipped away all the faults, and so I like this. I think this is great.
Yeah. So what was happening? Yeah. Like, sorry to respond to that. It's really important to realize that we all have to pull ourselves up by the bootstraps when we learn to program a new language and when we learn new techniques in a language. You can't expect yourself to like innately know all these weird things, and it's complicated stuff. What I was doing wrong was, and I'll explain it, you know how I said never ever ever do that, never actually ever put that inside here. It's the same reason, same bug I just had. The problem was when I had that if I equals 50 outside, it would run through the for loop, schedule a bunch of go routines, likely before the very first go routine ever started. Especially if, this is running on a back-end server in the cloud, and they only have set it so it only uses one process or one PID. It very well could have been scheduled to have, run through all 100 iterations, and it never scheduled. It scheduled all the go routines, and only after the wait executed to block the main process or the main go routine, then the go scheduler said, well, I got 100 other things I can work on. But by then it was too late. We already reset it before we ever set it. So that is the exact problem we had. And I'm going to reformat this in typical Go style. Whenever you start a sync wait group, you always want to do your add before you spawn your go routine. Part one. Part two is if you have a variable that you want to be used inside the go, or if your loop variable, if you want to use that inside your go routine, you have to close over that loop variable. Okay, I'll just call that J for here and J here as an example. I think that's perhaps a better example. Anytime you want to look at your loop variable inside your go routine, always close over it, or you're going to have a race condition. Is that
because the loop variable is going to change?
Yeah, the loop variable, because it's indeterminate what order the Go scheduler. The Go scheduler is designed to be indeterminate in terms of what order it runs the different processes. It has to run them in what's logically correct as defined by your program, not necessarily in what my imagination thinks it will run when I write the code and forget how the scheduler operates. We don't know, every time we spawn a Go routine, we don't know when it's going to run. By the time that Go routine runs, I might be a different might already be 100. And in fact, we can even do that. Let's take a look at what that I is. I'm going to func.println I, and take a look at the output. It's going to surprise you. It's going to range in, let me also change that to, I'll do 50, and I'll change that to 25. So take a look at this. What I is 50 the entire time, which tells me this loop executes all 50 times before a single Go routine is executed. The main loop completes because we don't know the order. So again, if you're ever going to use your loop variant, I don't know what they call it in computer science world, it's been too many years for me, please close over it and save yourself the hassle. You're even better off if you rename it so you don't make the mistake, because you could I mean, you could call it the old name. Maybe that's easier, but just to prevent yourself from making that mistake.
Can you print line J, please? That'd be interesting.
Absolutely. I would love to. Ready? Think. So Y, oh, J is 49, and then it goes down. Why is J 49 there?
And the last one gets scheduled first.
Oh, there we go. Because we don't know the order that they're invoked at. Duh. You're absolutely right. We don't know the order that the go routine. So we almost are naming this go routine. We're naming it with the its iteration, right? We're saying, hey, this was instantiated. This go routine was spawned off with I, which is its iteration number. Inside the go routine, it is actually called J, and that's the name of the go routine. This is the 49th go routine to be spawned, yet it is the very first one to execute. And then all the others are in incrementing order, but there's no guarantee for that to happen.
Could we run it again?
Sure.
I want to see how messed up
Ready?
this is.
Format. Okay, scroll up, and I'm gonna hit the run button. Okay, take a look at this. It's getting, GoVet is giving us an error because it's saying, hey, dummy, the loop variable I is captured by a function literal, which is beautiful. It's telling me that there's a problem in my logic, and that is I'm capturing over I, and I should not capture over I. That's actually really cool that GoVet is doing that. But that's what that error means. It means you set your loop variable I, but you're calling a function here and you're closing over it with that variable. It's not going to have the effect that you want, and you can see it does not. Initially, you'd think that I would be 0 through 49, but it's not. It's not 0 through 49 at all.
Hey, Carrick, how did you execute GoVet just now?
That's built into Go 111. When you go build or go test it, it runs GoVet for you, and it's a lot more informative.
Okay.
So, like if I run Go format, you can see it's not Go vetting, which you kind of think that Go format would also run GoVet, you would think. But then when running it, it's giving you that output.
Nice.
Cool. So yeah, if you see this error in your code, you're knowing you're making a Carrick mistake, and you should not do it. Even though I did not make that mistake right now, I made a similar mistake.
Nice.
Okay, so this is actually, this type of once with a reset is going to be much more performant and less race condition like than the library you mentioned earlier. This is using the CPU and doing this is a single operation to reset the once flag. And this is a single operation, single CPU instruction to, hold on a second. I'm on call today, so I have to make sure that it's not things breaking. It's a single CPU operation as opposed to anything else you might need. Here's something very cool. We can get rid of all that jazz. I wonder if I can do this. Let's see. Run. Nope. Oh, yeah, duh. I want to say it's an address, so run it. Okay.
You need to get rid of your receivers on your functions?
No, I thought those are fine, but I might have to do a casting of it.
I think you do.
Yeah, let's do that. Uint 32.
Is the cast atomic? Like, does the cast keep your function atomic?
Yeah. So, that's a good question. Because it's a type declaration, the line 12 is so line 12 is merely saying once is a uint32. A cast is a hint to the compiler saying, I know that this actually is this data type, but clearly I don't have all the right casting bits. So I'm going to go backwards and go back to something that we know works and not do that. So it's something that we can do. It's just I need to actually spend some more time thinking about the cast and not trying to rush the work.
Cool. Hey, Carrick, can you
Source code?
share the link to this?
Yeah, absolutely.
Maybe just do the share button and put the link into
I'm just making sure I fixed it.
Okay.
Okay, I'm putting it into Slack.
Okay. I'll put it into the,
Well, I've already got it copied. You don't need to, unless you want to.
I just wanted to put it into the doc.
Oh, okay, cool. Will it disappear? I don't know.
Could you put it in chat?
I'll put it into the doc real quick, and then I'll put it in the chat.
I think I'm going to make a library out of this guy because I think it's a much more simple library than I should probably use if I'm signed in on Chrome. Nope. GitHub. Oh no, I'm not going to worry about that right now. I'll do it later. I could make a Git, but it's not worth it.
All right. Okay, folks, I have to go. I've got an Athens development meeting that I'm late for. So next week we'll be back. If you've got ideas for stuff that you want to talk about or you want to hear about or learn about, put them into the doc. I put the link to Carrick's code on the Go Playground and a link to the doc in the chat. So with that, see everybody later.
Take care, guys. See ya.
Bye.
Bye bye.
Very much.
Thanks for everything.